So hey guys, welcome to this video solution of Codeforces round 652 div 2 problem B. This was the second problem and it was a really great problem and it involves some computation on strings. So here is the problem statement. You can read the problem, but if I try to explain your problem in the simple terms without missing any important point, then the problem is something like this. So here this is just the story part. The here main problem starts from here. So here we are a string is given to us which is a binary string. So binary string is basically a string which contains only zeros and ones, and in one move we can do the following operation, which is we can choose two consecutive character si and si plus 1, but only if si is 1, si plus 1 is 0. That means we can choose any two consecutive characters such that the first one is 0 and the second one is first one is 1 and second one is 0, and we can erase exactly one of them. That means if there are some strings something like 0 1 0, then we can choose the second and third 1 and 0 and erase at least one, exactly one. That could be 0 or 1 according to our choice. But there is also a caution that we can't just delete both of them. We can only delete one of them. So this is an important point. We should keep it in our mind while going through the solution. And there is another constraint to us, that we can make any arbitrary number of moves. That means we can do this operation any number of times, but we like the string to make a clean to string to be clean. That means the string should be clean after the operations. He thinks that two different strings x and y, the shorter string is the cleaner. That means the string with lesser length is cleaner. But if there are two strings with same length, then the lexicographically smaller string is more cleaner. So we have to make this given string cleaner such that the cleaner string is such that the length is the smallest, and if there is two ways which gives us the same length, then we have to choose the lexicographically smallest one, smaller one. So we would be given test cases and we would be needing to solve it, and here is the sample input output. So let's move to the solution and we will be discussing more. So here is the solution. We need to make some observations before concluding to a solution. So basically there was just one major observation which we have to make, that was that how can 0 and 1 be combined. So from this input, if we say, let's consider this third case, this third input. So n equals to 8 and the given string is 1 1 0 0 1 1 0 1. So now, so basically now let's see the operations which we can perform on it is, let me just make it better for readability. So in one move we can choose two characters, so we can choose any two characters such that the first one is first one is 1 and the second one is 0. So like in this, if we see that we can choose these characters because first character is this I is 1 and then this I plus 1th character is 0 here, and we can also choose these two characters because this ith character is 1 and I plus 1th character is 0. So we can choose these two characters and perform the operation on it, but we have two options. So if we see in this string, we can, on while performing operation on this, we can make it something like this by removing this 0 and taking this 1, or we can make it something like this by removing the 1 and taking this 0. So we have two options, either we can do any of them. So now let's see even more clearly. So basically when this condition would become that the ith character is 1 and then I plus 1th character is 0, so the situation would be something like this. There could be some another part here of the string and another part here. So if we just zoom in and observe at this point of contact between 1 and 0, so basically here we have to perform an operation, and in the operation we have to choose either one of them and erase the other one. So now let's see how can this operation be performed, keeping in mind that at the end we have to get the minimum length. That means this entire thing should be giving us the minimum length. So we need to find the minimum length out of this. So now let's see. So basically there was very interesting thing which we can do with this. So basically let's first use this 0 and keep combining it with these ones here, 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 and this one. So, and on this operation, suppose we first we perform this 1 and 0 operation, and from that we choose 0 and deleted 1, and then we did this 0 and 1 this one in this operation. So basically let me just write the array, that's 1 1 1 1 0 1 0 0 0. So this one is erased in the first this operation. Then the string is something like this. So in the next operation, when we do from this one with this one, we can just again choose this 0 and take this one. So the string length is decreasing because the ones are being continuously removed. And now with the operation with this, which was if the original string we see between this and this one, because between this and this one, because these two ones are removed. So in this also we can take this 0 here and remove this one. So now we have these two, we can perform this and this, these are these one, this one and this 0. But while performing operation on this, we can again choose the 0 out of here and delete this one. So now we are remaining with just one, and we have reduced the length from this long to just this. Now here we need to change our approach because we want to make the length minimum. So we can use this one and do the same as this 0 has done on all these ones. We can use this one and do this to all of them until we reach the last 0. So while performing the operation, first we will perform on these two, then the string would become 1 0 0 0, this 0 is erased. Then we will do on this, then the string would become 1 0 0, this 0 is erased. Then after this it would become 1 and 0. So the smallest length basically is achieved, and after that we can again perform an operation because it is 1 here and 0 here. So after that we have two options, either to choose 0 out of it or 1 out of it. We can choose any one and remove the other. So for this, if we see that the second part of the question which states that we can make any string, but we also have to choose the lexicographically smaller string. So basically if we see what is the lexicographically order, so let's suppose we have two string this 0 0 0 0 1. So the string is called lexicographically smaller, that if we move from here, then if these two characters are same, we move forward. If these two are same, then we move forward. If these two are same, we again move forward. But here these are different. So suppose this was string x, this was string y. So if the character which differ, the first character which differs from this side, we observe when we see the one which have the greater character is the greatest. So in this case x is greater than y because this is the first position. If we look from here where these two characters differ, and this one is greater than 0, so the x is lexicographically greater than y. So now let's consider again a simple example. Suppose the x is this and y is again this. So in this case we see that from here the characters are same, here characters are same, here characters are same, here also the characters are same. Since all the characters are same, so lexicographically we can say that x is equal to y. So this is the basically lexicographic. So basically if we want to make this, since x was bigger than y, so we can make this x equal to y if this position had 1, or if this position had 1, then x could become smaller. So similarly in our case, if we see, so from this entire string we can extract either 0 or 1, that is according to our choice, by doing this operation like choosing 1 0 and moving till the end, removing all these. When with the last one we move to the right and again remove all the middle zeros, and at the end we have a choice to choose either this 0 or this 1. And we have seen here that the string which has lesser character at the first position which they differ is lexicographically smaller. So basically if we see that choosing 0, that means instead of all this place we can place, if we place 0 in a string, then if this that would be compared with any other string, then it would be definitely lexicographically smaller or equal to that other string. So let me just explain it a bit more clearly. So suppose this was our string, so this, okay, so this was the string. So basically if we see that this all things just resembles this part over here from there to here, that means we can that this whole block can be changed to either 0 or 1. So from this we can make a string like 001 or 010. So if we see that this position is in our hand, that what we want to put, we can put 0 or 1. So to make it lexicographically smaller, it is always better to make it 0, as if we just like this compare these two strings, then this position is equal, this position is different, but the one with 0 is less, so x, this one is x, this is y, is less than y, as this position is the first position which from left to right if we see which differs, and the character at this yth form of the yth string is greater, so x is smaller than y. And in the question it is given that we have to form the lexicographically smaller string if the size of these two strings are equal. So the size of both is 3, but we have, by putting 0 at this place, we have made this size smaller. So basically this was the entire observations, that how can we combine and zeros and 1. So if I just summarize this point, that so if there is this some string from here to here and here it is 0, so basically suppose 1 starts from here, then we have some zeros and some 1 0 and this continues, so we in this continues till the end. This is a big string and we are just zooming behind into the sum part where there is a conjunction of ones and zeros. So this entire block can be replaced by either 0 or 1, and we have seen here that replacing with 0 is much better, as it will be leading us to lexicographically smaller string. So we will be doing this approach, that we will be replacing this entire part with just 0, which will give us the lexicographically smallest part of this string, and we will be doing this operation at all the position of the given string. So let's take an example which was given in the question also, this one, the third example again. So the string is 001101. So here if we see that the first junction of 1 and 0 is here, so all the ones can be combined as seen here. So the junction, all the ones before the junction 1 can be combined, and all the zeros after can also be combined. So this entire can be called as a block. And if we see here, this, oops, just one moment. And if we see here, this is a junction of 1 and 0. So the entire block of 1 behind it, so this one is here, an entire block of 0 after it, say 0, though we cannot do anything, can be clubbed. And from this we can either get 0 or 1, 0 or 1, and we have to get the lexicographically smaller, so we'll definitely go for 0. So from this we do 0 0 1. So here this should be the answer, and it is completely, I made another mistake, one moment please. So basically if we see here, so here we have to make another observation. So I just covered for one part. If there is just one string, then we can choose either 0 or 1. The 0 would give lexicographically smaller, but if there are more than one, then here we can extract 0 1, here we can also extract 0 or 1, and this one cannot be changed since it is not in a part of a block. So if we see that, what if we can reduce this also? So basically suppose here we chose 1 and here we chose 0. So from this we can make it even smaller, because these would be, so this became 1, this became 0, the string become 101, and here another we are looking for at a block. From this we can extract either 0 or 1. So from this we would be extracting 0, and 01 would be the final answer, which is the third case here. So this was the part which I forgot, but I explained it now. So basically the approach is something like this. So from this block of 0 and 1 we can extract either 0 and 1. So from this also we can even further reduce it to but single 0 and 1, and this would be the final answer. So if we see for multiple blocks again, so suppose there are this. So these are basically blocks of 0 and 1. So that means there is something, a string, we are just classifying it as a block. suppose there are some zeros, so if there is 0 present, then it would be coming here, not outside this block. So suppose there is just 1 present. So if we see that from these all blocks we can extract either 0 comma 1, from this we can extract 0 comma 1, this we can extract 0 comma 1, from this we can extract 0 comma 1. So now if we see these all blocks again can be combined together, but what would be the best way to combine this? So if we see just like the string which is here, this, if we see just like this small string, then we can make it like 1 0 0 0, and using this one we can move ahead, combine this, and when we reach the last, then we would be having 1 0 and this one would coming directly. So from this we see there is a block, and from this we would extracting 0 and 1. So this would be the final answer if the given input was this 1 1 0 0 1 0 1 1 1 0 0 1 0 0 0. So for this and the last there is this one also. For this the final answer is this. Using these blocks we can just form 1 in the first position and then combine 1 with all the zeros, and in the last we can get this 0. So basically if we also conclude that from all these blocks, what did we finally got? We finally got this 0. So this was the main observation, that we should be first forming these blocks, and then from all these blocks we would be finally getting this 0, and if there is something present at the end we will append it. Also if there are some zeros present here, then we cannot do operation on these, so these will also be in the. So let's get to the code for appending. So here the code. So here was the code. Let me just put main parts. Here is the main part which starting from here. So here I am handling the input part, and what I am doing is, like if we see for this example only, so let me just make this more readable. Okay, so here in this block I'm just forming a vector of pair which is called array, so which contains the character and the count of that character. So basically if we see this is 0, this is 1, so I am just counting 1 which comes twice, then after that I am counting 2 which comes twice, then I'm counting 1 which comes once, then 2, then 0, this is 0, I sorry, this is 0, this comes once, this very next part is 3 times, like this. For this entire array I'm counting this vector, the count, so this will help me in of this box. So is just able to show that are there any starting 0 present, because these zeros are also to be handled and we cannot just club them with any other. So for these I am just counting that, I'm just iterating from this in this vector. So suppose if there was some 0 for size C, so first I'm just printing these 0 times in this loop, and after that, so if so what is also in case which you need to handle, that if all of the character are 0, so if all limiting all these, then we would be standing at the length and at the end, so we don't need to do anything at that point. But if this was the case, so there was actually no 0 in the case which example which we are taking, so we will not reach at the end. So for this case, since we are not reached at the end, so I am just checking that were there any initial zeros. So if there were any initial zeros, so we would be having some block like this. So if we can see that if we have odd number of blocks, these are odd, right? So if they're odd, then for the last block, for the last one, so I'm just in the implementation part is slightly different. I am also considering this as a block, this as also for I'm checking if there are odd number, I'm just printing this one for the last position which was 1. I'm just counting which is will be stored. If there were, and if the else part would be like when there was no initial zeros. So for that I'm starting from here and just putting this initial zeros which would this would be formed here by combining all these. And if the size is odd, if this entire block is odd, so here I am, let me just make this thing more clear, I think it is causing some confusion. The blocks, let me just 0 0 1 1 0 0 1 1. So basically if this is the block which I am referring here is this, I have formed a smaller blocks, and if there are odd number of blocks, so suppose we can pair all the even pairs, so 1 2 3 4, and if there are odd, that means this last block would be left, and that block just I am printing the count. If the count of this is 2, so I'm printing one set, I'm just printing 0. This 0 is present behind it. So now I think the approach is clear, and I'm sure you would be able to implement it on your own. So if you like this video, do subscribe to the channel, comment below if anything you did not understood, and if I was able to make you understand this problem, do give this video a thumbs up, and do check out the other video which I would be posting. Thank you for watching, guys.